welcome everybody to the last class of Linux and Electronics, a Raspberry Pi course. Today we're going to be doing a fun class. We're gonna have a fun class. This is where everything that we learn comes together, and hopefully after this class you're gonna be able to do some fun stuff. Okay, so now today we're gonna be I/O scripting. We're going to be doing some scripting for the pins that the Raspberry Pi has, and we're gonna be using three of the components that you got on your kits. Okay, so a reminder from the last class was that there's a library called GPIO which we use on Python, which comes by default on the Raspberry Pi image. So there's two types of way of declaring which kind of numbering system you're gonna be using. One is the board, which is going to be these numbers at the center, 1, 2, 3, 4, 5, 6, and so on. And the other ones are going to be the BCM, which are the numbering system from the chip that the Raspberry Pi uses. For example, if we're using BCM, we're gonna call this pin GPIO 14. But if you're using the board, we're gonna be using 8, all right? Okay, so we're gonna do again some blinking. We saw that the last class, but today we're gonna add something more to that. So a little reminder, and I'm going to be explaining what we, in case you didn't accomplish during the last class, now I'm going to give a full explanation. So an LED is an electronic device or part that when you put current through it, it lights up. So it converts current to light. And it has a polarity, which means that you cannot put it in one way or in both ways. You have to put it a certain way. Imagine a battery which you have a positive and negative. The LED has the same polarity, right? This is a resistor which your kit came with, and this device, electronic device, doesn't have a polarity. So you could have put it in one way or the other. But the LED, you should put it in some way specifically. I like this image because it tells you how to tell which one is the positive or the negative, depending on which kind of LED you got. Some LEDs have this part cut it off, so you can know that that side is a negative. What I usually do is that I put the LED in front of a light, and I see which is the smaller part inside of the plastic colored part of the LED. That's gonna be the positive. Also, I don't know if you noticed, but also depending, they come in two sizes. So that's also another way to see which one is which polarity each one. Not only the sizes, but some LEDs have this bended, this pin bended, so you can also know which one is the positive and the negative. So last class I explained how each part of the breadboard, how each pin connected to the other one, so you can make a circuit, right? So yeah, here, as you can see, this pin is connected through this cable, and this pin is connected through here, all of these pins, but for the circuit, it's only connected to the resistor for the circuit's sake, which makes a closed circuit here, which is redundant, right? And once we put a signal, it should light on. So this was an example of what of a simple LED script on Python should have been, or it is. We create the Python script, we give it permissions. As you see here, it's missing the plus X, right? As we all know, X because of executable. And then you need to execute it after you add all the lines on the script. So let's go over the script one more time, a little bit quick. Here we import it here on this part until here. We import the library, and then we use this. I don't know how to call it, but we use this part to call it, to say that we're gonna call it this way. In Linux, there's a command called alias, which it's working like this one. Every time you call this, the program knows you're meaning this. This is important because if we're not using this one, we need to put the Raspberry Pi dot in front of every time we put GPIO on this program specifically. And then from the library time, we import in the program sleep, which we're gonna be using for timing and delays. Here we set some warnings off just in case we don't want them on the console to be popped up. Then we set the mode, which is what we were explaining before. The GPIO system that we're going to be using is the board one, right? You can use either one if you want to test it, that's fine, but you need to be aware of that. And we're setting it up as an output. GPIOs or general purpose input outputs are pins on microcontrollers and single board computers as the Raspberry Pi, which they can act as an input or as an output. You need to declare how it's going to behave, and then you put it into use. For example, here we're just gonna use it as an output. And this program, this part of the program from here down, while true in Python, means that this is going to run forever. This is not going to end. So it's just a forever ending cycle. As long as the program is running, this part of the program is going to be running. So we use this part from here up as to declare things for the program to this down part of the program run correctly. So here we do sleep 1, which means you're going to stop the program for 1 second. Okay. And then you declare this pin as a low. So we send a GN, we connect it to the ground signal. And then 1 second, we stop it, and then we go high again. Okay. We'll put it high. If you run that program, then you're gonna have a forever blinking for and it's going to blink every 1 second. That's what you're going to have. So let me go ahead and connect to my Raspberry Pi. Okay, I have it here already. So here we are on the Raspberry Pi. Someone asked me to put it on full screen. Let me see if I can put this more default size. Yes. I can put it a little bit bigger. 20 maybe? Oh no, that's a lot. Wait a second. Let me put this 16 maybe. Yeah, that's gonna be fine. Okay, so let me enter to the here. So as you can see here, I have a couple of programs which you're gonna be seeing this class today already made. So let's see the LED.py, which is the one that we saw. As you can see here, this is the same program that we had on the presentation. So if I run it, Python 3 LED.py. You're not gonna be able to see it, but my LED is lighting up. Oh, one important thing, which I almost was forgotten. The resistor needs to be um, a certain amount of has to have a certain amount of resistance, which is measured in ohms, OHM. You can find it. I usually once when I if I ever forget, I usually search it on Google. I search LED red resistor Raspberry Pi, and usually they tell me which one it is. After that, as you can see, they don't have numbers. They use something called color code, which you can also find on the internet. You can each color means something. The first two means the first two numbers of the resistor, the N resistance, and the third ones means that the first two numbers are going to be multiplied by 10 up to the number that represents the third band. Okay. So in case you don't know and you don't want to go too deep into that, you can just search a color code. Adafruit has one, and many sites on the internet has one. You just put the colors, and it's going to tell you which resistance you have in the hand. So each LED, depending on the size and also the color, has different resistance requirements. Usually from there's you can put a 200 ohms resistor in there and you're gonna be fine. Okay. So but in this case, I mean in the Raspberry Pi. Okay, so let's go over here. So yeah, so as you can see, we're going to connect it to the 40th pin on the board, let's say numbering system, which is this one. I used these two, so I connected the negative or the cathode from the or negative part of the system, which you can just put it, for example, the resistor could have been in positive or negative for this case, okay? So you could just put it here and connect the positive right on the LED and the resistor between this pin and this one. But what I chose to do was to put the negative right from the resistor, put the resistor to the negative or the cathode pin on the LED, and the positive to put it on the GPIO 21 or 40th in the board nomenclature system. So this is the other program that I did that I'm going to show you. In this program, the LED, as you can see, we have this part almost the same, but we changed this part so you can see some cool things about declaring the variable, a variable with the number of the pin, and you don't have to change every time you need to be changing from system to system or pins from pin. You only need to change once the number. So you declare this variable called LED underscore pin as 40, which means that that's going to be the 40th pin, right? But that doesn't mean that now. It's going to mean here. Once I call the setup function and I call here. So this, and as you can see, this and this are the same, just I'm using a variable. So here. So then I declare as a low first, so because that's going to be my normal state in the program. And then as you can see, I made another while true, which means this part of the program is going to be run forever. Here are some fun stuff. Let me put it full screen so I can explain better. So this program, subprocess, as you can see, I imported another library called subprocess. This allows me to run commands on the Linux console, but from a Python program. This is not the only program that does that. This is not in any way, so you can find more programs in case, but this is kind of a standard, and yeah. So first of all, I'm going to call another variable, and I'm going to put a string into it. This string, I know it doesn't look like it, but this is a command from Linux, confine, which is for finding if there to find and search directories and files in Linux. So I'm looking for this file in the same directory that this program is running on. This program right now, as you can see here, the LED OS is in the desktop. And if I do this, by the way, if you want to stop a program from running, you just click or you just press in your keyboard Control C, which is going to trigger a keyboard interrupt for the Python console, and it's going to tell you to stop. This is going to, here, as you can notice, this is my traceback. This is going to tell you when the line stopped. So in case you want to debug it, sometimes it has helped me to debug when a program is stuck. So yeah, as you can see, I'm in the desktop, and as you can see, I have the LED OS program in my desktop. So this program, find here txt, we're gonna run it. I don't think we have, yeah, we don't have the file here txt. So I'm going to look for it. There's no file in directory. If I do a touch here txt, which is going to create it, as you can see it right on top here. And then I do the program again, you can see that it is there. So let me delete it. There you go. So we're good to go. So here's the program. This is a way of calling this function of this library, which is called call. You put here the program, you tell the shell to be true. This is something, don't worry about this. If you're gonna use this program, I suggest you to read it, but for this purpose, it's going to work just fine. So I'm basically making another shell to be popped up, and it's going to run this program, and the result of that is going to go here on this variable that I just created here, which is called process. I'm going to print process, and if process is 0, that means it found it. It found the file, and everything else, any type of other output is going to put the LED low. So I want you to try that to make this. You can also do more fun stuff as putting the cron tab to create a here txt every 1 minute. And maybe putting here in if we found it, put some 5-second timer, and then call the process to delete it. That could be fun, right? So I'm gonna test that right now. Hopefully everything goes well. Python 3 LD OS. Okay, so as you can see, it's going to be running forever. Right now it has a output of 1. I don't know if you remember from, I think it was the second class where we were talking about the standard output, input, output, and error. So usually a standard error gives you a 1 as an output. And as an standard, and if there's no error, it's going to be giving you a 0. That's why, and let me check here so you can see that it's the same program. That's why when it's a 0, then the GPIO, the pin 40 goes up and it turns on. So let me run the program again, and let me show you as I here create a file called here txt. As you can see, once I created it, right away it started to found it, and then the output became 0. If I delete it, you can see that it doesn't find it. So yeah, that's what these programs do. So you can do this, like imagine you can do a turn the LED every time a backup file is generated or something like that, or turn a something up like a AC or something every time the backup is made with the cron tab, for example. So you can do fun stuff with this, right? So this is a way to interface things that are happening in the operating system to the real world with an LED. So let's talk servos. This is the second part that we're going to be using from the kit. Servos are a type of motor that are made from three things, basically. A potentiometer, which is going to be reading where the gear, the outside gear, is going to be. A circuit of control, which is going to be doing that conversion from the signal you are given from the microcontroller or the single board computer, reading the potentiometer to make sure that if you tell it to go to somewhere and it is already there, the circuit knows and doesn't move the motor, and also to control the motor to move whatever it has to go. So the motors that you have, which is an SG90, if I'm not mistaken, has it looks something like this, but smaller. This is a bigger one, okay? These gearbox are used to make the high speed, low torque motor to convert energy into low speed and high torque. That means that you can move bigger things with these kind of servos. I mean, with servos, compared with the motor that is inside of it. Okay. So they are controlled with something called PWM, which is a kind of signal that you can get from microcontrollers and single board computers. Right now, the Raspberry Pi doesn't, as I'm aware, it doesn't have a pin that has a PWM, let's say, from the controller. The Arduino has it. Some Arduinos most of Arduinos have them, have a PWM output. If not, you can create it, which we're going to do here in this part. So what a PWM means, it stands for pulse width modulation. That means that you're gonna be sending a pulse, and this is the part that you're going to be modulating, right? You're gonna have a standard time, which is going to be like the hertz that device works with, and then you're gonna change the time the pulse is on, and that's gonna mean something for the part that is connected to. If you, for example, call half of the time, is going to mean something. If it's full or if it's low, etc. So if we're talking about the servo and how does that goes with the servo, if we send a pulse with the smaller type of the small pulse, it's going to, for example, go to 0. If we go to the max pulse, it's going to go 180. Have in mind that the amount of degrees that the servo that you have and other servos go to is going to be independent. So you need to search for your model of servo and look for how many degrees does it have. The links that I'm putting down here are really good resources to look for. So I'm probably going to put them on the class notes, but you should look for them, okay? So how to connect the servo to the Raspberry Pi? The servo that you probably have has 3 cables, colored red, brown, and yellow, or orange, I'm sorry. And the red ones means that's the positive, which you're going to connect to the 5 volts. The brown one is the negative, which is going to be connected to the ground. And the third one is going to be the orange one, which is going to be connected to whichever pin you want to hook up with. So have something in mind. Depending on the brand that you get, you have a different coloring system. Usually the red stays the same, and the dark color, which is probably black or brown, is going to be the negative. And the other color, in this case, are yellow, orange, and white, are going to be the signal. So that's the pin that you're going to put on the pin that you're going to control it with. Okay, so this is the program that we're gonna be running on. Okay, this is a standard, right? Here we called for the GPIO pins. Here we're looking for time because we need to be to have some delay. Remember that when we're working with mechanical parts, sometimes you need time for them to move. So it doesn't matter if you take this out, but this is probably not, this command is not going to end before this one starts running. So you need to put some time between the commands when you're working with motors, as this one, or for example, stepper motors, so it can move, okay? So here, we're gonna be using the 11th pin of the GPIO board standard, and we're gonna put it as an output. Then we're gonna call the PWM function from the GPIO. We're gonna put it to this pin, and then we're gonna put the hertz that servo is working on. Okay. The start means where it's going to start, as for example the initial movement. So here, this is where the program starts. If you run this program, let me do this right now. Let me show you that I have the same program servo. Here, import the pin, set mode, setup, PWM, start, and the duty cycles. The duty cycle is something that you can calculate of us, the PWM that you're gonna be using. So for now, you can just, for this example, you just can think that the numbers that you're gonna be putting here is going to be from 1 to 12. So this is going to be 1 is going to be like, let's say the 0 degree from the servo, and the 12 is going to be the 180 degrees. So here I'm going to call it to the 0 degrees, for example, and I'm going to call it into half. So let me run this one. 3 servo. As you can see, I'm getting some warnings, right? So this is what we disabled in the other program, which we have in here. So I wanted to show you what happened. Right now, I don't know if you can hear it, but my servo is moving. And it's moving from the 0 to the half every 2 seconds. You can change any part of this program and it should work just fine. Okay, so here I stopped it and my servo stopped too. Okay, so let's talk about I squared C. Okay, so I squared C is a type of serial communication. You can imagine that I squared C is as to the Raspberry Pi as an USB is for the computer. It's a way, it's a type of communication bus that where you can connect things in the same two pins, and you have them communicate, let's say, all of them at the same time. Depending on the I2C bus supports many devices. If I'm not mistaken, up to 260 and 56. That's because of the addresses. Okay, so the I2C has a number, a set number of addresses where you can put some device into it, and and every time you want to talk to that device, you're gonna call it for that address, and we're gonna be looking that in a little bit. So first of all, we need to do something that we did on first class, which is going to be enabling the I2C interface. Okay, in the first class we enabled SSH. I showed you both ways. The first one was with the file, once you flashed the SD card, and the VNC, I think it was in the second class, in order for you to do this that I'm doing, which is like basically Team Viewer, like for the Raspberry Pi. So we click enable, we hit OK. If it asks us to reboot the Raspberry Pi, you should do it. If it's not, then you should be fine. So, so the LCD that we got is supposed to be an I2C. These pins should be connected to this board, which is going to make, if you ever work with Arduino, you know that there's a way to connect this Raspberry Pi to an Arduino, connecting each one of these pins. But once I found out that you can put this board, solder it into it, either they come soldered or you need to solder it. So you put it, and you only need these 4 cables to connect it to the Arduino or the Raspberry Pi. So this is way better. You have less cables, more reliable. It works as fast. It's basically the same. So if we're gonna connect it to the Raspberry Pi, you should put the red one or the VCC one to the 5 volts, right? You have 2 pins. You can use either one. If I have my servo, my LED, and my LCD all connected at the same time. So if you can just put one in one VCC and one in the other one. The GND on the negative is going to be on the negative, right? And the other ones, which are the 2 cables, which we can see here. These are the 2 cables that carry data. One is called SDA and the other one CLC. Notice that you should connect each one of them to the ones that are on the Raspberry Pi. For example, you're gonna connect the SDA to the SDA pin on the Raspberry Pi, okay? And the SCL to the SCL of the Raspberry Pi. So we're gonna do something that is basically like a lookup. Let's look for, it's something like we did with the Nmap in the first class, to see what IPs are on the network. This way, we're going to be looking what devices are connected in the I2C bus on the Raspberry Pi. So let me clean this. Oh, that was fine there. So we're gonna do a ls dev, which is going to show you, which is going to show us all the devices that we have on this directory. As you can see, I have the I2C1 available. Some single board computers and some Raspberry Pi and some Arduinos, excuse me, microcontrollers, are gonna have more than one I2C bus. So have that also in mind. In case that, for example, which has happened to me before, the I2C you buy, for example, two LCDs, and both of them have the same addresses, then you can also simulate an I2C bus by doing a program, and it's not going to happen. It's not going to work as operating system wide. Like, it's going to run in the program. You can find it. You can see software I2C Python, and it's going to show you how to make the program. Is going to make it's going to take two GPIOs, and it's going to make them I2C bus. So that usually happens if you need to put more than one device, and some devices. What I mean is the same device. They usually can't come with the same address. Some devices or some manufacturers know about this, and they put some pins so you can change it. So if in case you're gonna be using more than one, you can change which kind of address is going to appear on that device, so you don't have that problem. So I have this one, right? And as we can see in the presentation, we're gonna to do a command which comes from default on the Raspberry Pi, which is I2C detect. And with this flag, we mean the first I2C device. Let's do I2C, man I2C detect. So detect, I2C detect. Here. So let's look for what that Y means. Okay, there you go. Oh, okay. So let's do I2C detect Y1. This is a map of the devices that are here, right? As you can see, my device is on 3F. This is important, and you're gonna see why, because in order for us to talk to the device, we need to know to which device we're talking to. Okay. So here, so the I2C driver that we're gonna be using is not going to be stock. It's going to be from a third party. The link is down here. You can just search it as Circuit Basic I2C LCD. It's a good tutorial. But we're gonna go down to this part. You can read it, all of it. But we're gonna go down to this part and installing the library. The library is basically this code. You can just copy and paste it, as I did. Here is where I copied and pasted, as you can see. Here, LCD right chart. Here, LCD right chart. As you can see, I just copied and pasted it. Save it as an I2C LCD driver. .py. Let me see if I can, if I gave it the executable. Yes, I give them the executable permission. And then we can just import that program, which is this one, to the any program that I wanted to be used the LCD. So let me see here. Here, okay. So something important for this library that we're gonna be using. Again, I created the file. You can name this whatever you want, but you need. I suggest you to put a very descriptive name. So I created the file. Then I changed the I2C bus and the address that this library was going to be talking to. This is important. So let me open this editor on the Raspberry Pi. And let me open this driver. In the beginning of the file, you can see that there's I2C bus and this is address. By the way, these configurations are specifically for this library of driver. Okay, so you're probably going to find a couple of ways to do this on different ways made by different people. If you go out on your own. So the I2C bus, we just put it came by default with 0. I put it on 1. Why? Because when we did here, let me do it again. When we look for the ls div, we can just grab the I2C, right? Because we know how to search for a specific query inside of our result. Here, as you can see, I got the I2C device, which is named 1. In case it was named 2 or 0, just in case, you need to change the library into 1 or 0 or 2 or whatever. So I changed it to 1 because that's the one we got. And also the address. It came with 27. Some I2C devices come with 27, LCD I2C. I changed it to 3F because, again, this is what we got. Let me do an I2C detect again with you guys. Oops, detect Y and 1. So you can see 3F. So you change it over here, only this part, save it, and then we're good to go. So the program that we're gonna be looking at is going to be this one. You're going to import it. Again, this program should be made. I did it here, LCD. This program should be made in the same directory that you have the driver in. For example, I'm in the desktop. I have the driver. I'm importing it over here in the first line. And I have the lcd.py right here. Okay, so I have them both in the same directory. I'm going to call it my LCD. Here, this function, the LCD function of the LCD driver library. I'm going to be called my LCD, and then I'm going to call the function display this string, which is going to be hello world. If I run this here, it runs on my LCD. In case this should run, if you have any problem, probably is because or either you don't have the I2C enabled. If you want to make sure enable it, reboot the Raspberry Pi through the system. Don't disconnect it and connect it. Okay. Then check again the I2C bus that you have, either 0, 1, or 2, etc. It should be 1 if you're using the Raspberry Pi 3. And go for here. And then the address of your I2C LCD. So this should run and it should show you a hello world. So in case you're not seeing it, try, this is something called, this is a potentiometer. This is the same device that we talked about that is inside a servo. This is basically a variable resistance, which you can use to signal that you're doing changing something like a knob. And in case you're not seeing, if you don't see nothing in your LCD, you just change this and tune it, because sometimes this changes the contrast. Okay, so maybe the program is running fine, but you're not seeing anything, maybe because of this. So have that in mind. Also, this part, as you can see, this is a jumper, but you can also use one of, in case your LCD didn't came with it, you can use a female to female jumper cable that it came with your kit. So you can put it right there. or you can just use whatever you want to short circuit. Once you short circuit, the back of the LED is going to light up. Everything should work, but if you don't have this LED turned on, you're not going to need some external light to see it. Okay. So this is the program, the cool program that we're gonna be using. You remember as we struggled in the first in the first three classes on getting the IP of the Raspberry Pi on our network. So I made a program that imports, right, the LCD driver, then import the subprocess, because we're gonna be using some command line tools with this Python program. I did the same. I declared this function of the driver, right? Then this is the command that we're gonna be sending to, okay, to the Linux, and this is if config. This is the device that the Raspberry Pi is using. I'm connected through my Wi-Fi to my router through the Wi-Fi in the Raspberry Pi. I'm going to look for this. I'm going to take this column, and that's going to be the IP. Then I'm going to run again. As you can see, this is not the same as before. We just called in the last program. We're going to run this command, which is this one. We're going to put all of these conditional, so arguments. And then the result of that, which is the std out, which is standard output, is going to be the IP address. Then we're going to send it again as a string, and then it should pop right into the screen of the LCD. Something that I didn't explain that I'm going to explain now is that this means the row that is going to show. For example, if you wanted to show in the row below, as you can see, the LCD that you got, it's called 16 by 2. So if you want to show in the first one, you put 1. If you're going to do it on the second one, you do it here. So if you want it, and also the 0 is where it starts. So if you want the hello world to be in the middle, you can just put the number 2 or 3, and it's going to be right. It's going to be you're going to justify by putting that. If not, you're just going to put it in the left. I'm sorry. So here, let me go to that program and open it up. Over here. So as you can see, it's the same program. We're going to run it. As you can see, it runs once, and it doesn't have anything, no specific output, because the output went directly to the LCD screen. It's not running forever because we don't have the while true. So in case we want this, for example, in case that the Raspberry Pi is going remote, we can just put this part of the program in a while true, for example, like this. Take this part, and when I do the tap, makes it inside. It tells the program, to this part of the program, to be inside of this part function, because this is a while function. So now it's going to be run forever. And as I can see in my screen, it's telling me that I have the IP 198, which we can see right here. Oh, let me show you what we were doing. Let me break down this command for you. This Python program, I mean this Linux a command. So if we run with a quick config, an if config, it's going to give you everything, every IP of each one of these. So if we had connected, for example, if you have connected the Ethernet cable in your Raspberry Pi, you should change this program to be, instead of WLAN 0, to be ETH0, and instead of iNet, you should change it to whatever IP. Probably it's the same iNet, okay? To whatever, whenever your IP goes on. So as you can see, I just put. Let me do this. If config WLAN, let me copy and paste it. I could just do that. So I'm only getting this one. This. I'm going to search for iNet. The reason I put a space inside of it is because if not, I'm going to get also the iNet 6, which is the IPv6, okay? I don't want that one because I'm not using that one to connect through VNC. So what I did just was a little hack, which is I'm taking this space too, okay? So I made this. So I'm only going to get this line. So as we also saw, we can use the awk command to pass, to search, or to give me as an output the second column, which is the one I want. If you don't know which one you want, I suggest you, if you are doing something like this, I should suggest you to do the one-liner in a command line. Test it, and if it works, then you know you can search it, and then you can put it inside your Python program, etc. Or on your Chrome tab too. That's very important. Okay, as you can see, if I did one, I was going to be passed this argument or this result, this column. If I do 3, I'm going to get NASMAS because, as you can see, 1, 2, 3. Okay, so what I chose was the second one to give me the IP that I have as a Raspberry Pi. So yeah, that's basically what I did with this program. You can do more fun stuff with this. As you can see, you can just search for the weather and have it pop it up every time you maybe don't want it while true. Maybe you just put this program, you put it back to normal, right? Back to everything back to normal. Oops. And then you want to do a cron tab, right? And then you go cron tab /e 1, and then we go over here, and maybe you want to know your IP every time it boots. That's fun, right? So, reboot, at reboot, Python 3, home, Pi, desktop, LCD, os.py. So if I have my LCD connected, every time it boots up, the Raspberry Pi should give me the IP. Something to have in mind, as we talked before, that you have to give it time for the motor to be moved, right? You remember that? Sometimes you just want you need to wait for the Raspberry Pi to finish booting. So there's a command called sleep, which is basically the same sleep that you have in Python. As you can see, it's the command line just slept for 1 second, here for 5. So if you ever want to make sure that you're gonna get for example, the Raspberry Pi still is booting up and you don't have the IP address, you just can do here like this. The first command is going to be sleep 30 seconds, for example, and then I don't remember if it was like this. Oh, it was like this, yeah. So at reboot, it's going to wait 30 seconds and then it's going to run this program. So that's what it's going to do. It's going to let the operating system to finish booting up, and then it's going to give you the IP address on your LCD screen. Okay. 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 So that was everything for this class. I hope you liked it. I don't know if you guys have any questions or if you want me to test something here with you guys. I don't know if you want me to make some program up, or what you, or if there's something you want to be explained again. Right now you can see the beauty of the Raspberry Pi, how it goes with making interfaces between the real world and the and software.